Good morning, everyone. Welcome to week 8 of Math 13218, Advanced Application of Mathematics. Today, we'll be talking about Euler's equation and system of ordinary differential equations. So we'll be talking about solving more than one ODE as a simultaneous differential equation. First few slides will be kind of boring. So it's establishing a theory. And once that's established, we'll practice some of the examples, right? So bear with me while we establish the theory and notation and a couple of other things. We will understand that, but have some passions while we go through it. Right. So when we talk about Euler's equation, we are talking about such a lengthy, higher order differential equation where we will have some x polynomial, x power n, nth degree polynomial differential equation, then Pnx, and again a polynomial of n minus 1 power and n minus 1 derivative, then n minus 2, n minus 3, n up to something 1 degree or a linear x polynomial with dy by dx, and finally p0y is equal to some function of x. Right. So what we do, we start by substitute. We want to make it very nice substitution and equation because this is too dangerous, too complex to handle. That's why we are using some substitution and exponential being one of the simplest and the greatest. So we'll convert everything in t and x, right? Rather than x and y. So we start with x is equal to e power t. Right? If x is e power t, obviously we call it t is equal to ln x, differentiation of t with respect to x. So it's dt by dx. Log differentiation will be 1 on x. Okay, we'll be making some substitution of all of this, but one by one. Okay, right. If x is e power t, then x inverse or x power minus 1 will be 1 on x is e power minus t. And therefore, your dx by dt, differentiation of this with respect to t, is e differentiation is e power t, and that is nothing but x. So we'll be using a couple of them. We'll be using this and dt by dx, and obviously both of this whenever we require. Remember one identity, e raised to I theta is cos theta plus I sine theta. And the Euler constant is e, and that's why we are replacing the substitution x is equal to e power t. Right. So we start with the basing thing, xy dash. Now we'll be using this capital D notation, d over dt. Okay, so xy dash. Now let's talk about y dash. What is y dash? Up here is differentiation of y with respect to x. It's dy by dx, right? Right. So what we do, we multiply and divide by t. I mean dt, right? Now what is dy by dt and dt by dx? So this is y dash t. And dt by dx, if you follow the previous slide, dt by dx is 1 on x, right? Times by 1 on x, right? Okay, what is 1 on x? Again, up here we have written 1 on x is e power minus t. So we'll write e power minus t along with y dash t. Now we wanted to use this d by dt. If you don't want to write y dash t to avoid any confusion, you can always go with dy by dt. That's also fine. Let's keep it dy by dt so we avoid some confusions, right? Now this is e power minus t. And as you know, d by dt, we are replacing with a capital D notation. So capital dy. Right. So this is your y dash. Okay. Now we wanted to talk about xy dash. So xy dash, which is x. What is y dash? Is e power minus t dy. Right. Now e power minus t is also 1 on x. So x times 1 on x dy. They both cancel out. And what we are left with is simply dy. So your x y dash is dy. But remember, d is nothing but d over dt. So that's our system being settled down. Okay. Then we talk about the next term, right? What will be our next term? X square y double dash. Okay. Now, what is y double dash? Let's talk about y double dash first. Is a second derivative. So it's a derivative's derivative, right? So dy by dx dash, right? I mean, don't confuse it with one power. So I'll write it in a way, dy dash by dx, right? So again, I will call it dy dash multiply and divide by dt, right? Same process, right? dt by dx is 1 on x, dy dash by dt, right? Or you can also call it d by dt of y dash. What is y dash? We just obtain it here. So 1 on x of d by dt of e raised to minus t dy. Yeah, y dash that we obtain, e raised to minus t dy. So we're going to differentiate that, right? So leave 1 on x here. What will happen here? The chain rule, the product rule, right? So e raised to minus t differentiation is minus t with a minus front dy plus e raised to minus t as it is dy becomes d square y, one more derivative. Okay. Now we use everything that we derived earlier. So x is e power t. What else we know? T is ln x, right? What else do we know? Dt by dx is 1 on x. Then we have all that thing, dx by dt is x or e power t, and 1 on x is e power minus t, right? We use all that thing to simplify my y double dash. Sorry, I need a slide here. I'll insert a slide here, sorry. Okay, so what will happen to a y double dash now? Y double dash, I'll go back to the previous slide. We have 1 over x. We have e power minus t. I just write it big nicely. I write d square y first, and then I'll take care of the minus dy. Okay, now what is e power minus t is also 1 on x as we just returned. Can I take d common and d minus 1 y? So finally, what I got is 1 over x squared d times d minus 1 and y. So that's coming up nicely. Now, if I talk about x squared y double dash, I'll multiply with x squared. So x squared and 1 on x squared will cancel. Right? And that will leave us with d times d minus 1y. Okay? So that is very nice and sweet. X squared y double dash is d times d minus 1y. Okay? Right. Now, by this time, you might guess the third one as well. So with the x, if you observe here, what happens is d, or simply d minus 0, if you wanted to write it in that way. X, y dash is d minus 0, y. Okay? So first power of x, first derivative, you're talking d minus 0. So one less than what's there. With the x square, you got two terms. D minus 0, D minus 1. So everything less than thing, right? Any guess with the cube? It should be D, D minus 1, D minus 2, right? Okay, so let's obtain it, right? y triple dash. We do the same process. We can always say dy triple dash, double multiply dy by dt and dx. Like simplified, this is 1 on x dy double dash by dt, and that's 1 on x. It is d by dt of y dash, of which we have e raised to minus d square minus d times y, the same thing which we had done earlier. And then we simplified 1 on x. Right? It's differentiation. So minus 2 e raised to minus 2t d square minus dy plus e raised to minus 2t d3 minus d is y. We simplify this, right? We keep on simplifying, combining everything, e raised to minus 2t, which is, 1 on x squared. So finally, after simplification, this will become 1 on x3, d3 minus 3d squared plus 2d times by y. Write it a bit nicely, right? d minus 1 and d minus 2. Yeah, times by y. Okay, and so finally, when you multiply with x power 3, that will be gone. So d minus 1, d minus 2 times by y. Okay, right. If we have to go for the fourth power, we can go similarly, d power 4, 4 times d minus 1, d minus 2, d minus 3, and y. Bit less, one less than the actual term that you have, right? And this is, if you want to write a bit differently, I would write it d minus 0, d minus 1, d minus 2. We are talking about n, so we'll stop with one lesser, right? And once you simplify this, that will become d minus n plus 1, right? So this was a bit of background on, how we will use it. Now let's look at an example and apply what we have learned. So you will have something like this: x power 3y triple dash x square y double dash 9xy dash and something. So compare it with the original Euler equation. We start simple: x equals e power t, therefore t is ln x. We are talking about only triple dash. So x3y triple dash from what we have obtained, d minus 1, d minus 2y, d minus 1y. This is dy. Yeah? Okay. We put everything up here. And remember, x squared is e power 2t, like if you need it here. But we already got it here, so don't worry about that, right? Okay, so this will be converted into dy x square y double dash will be d times d minus 1y. We got this negative 9 up here, so that should be retained, right? So it's not just dy, it's minus 9 dy is equal to 32 e raised to 2t, because x squared is e power 2t, right? Simplify where you can, keep the y term outside. What is this? As we know, it's d3 minus 3d squared plus 2d plus d squared minus d minus 9d y is equal to 32 e raised to 2t. Just simplify this. So you got d3 minus 2d squared minus 8d y is 32 e power 2t, right? Now we take the d common. D common left is d square minus 2d minus 8 y is e power 2t. From here, we make that auxiliary equation, the characteristic equation. We call it R. You could have called M or anything. So wherever you find D, call it R. R square minus 2R minus 8. Make it 0, we find the roots. So R minus 4R plus 2. You've got 3 roots here. R is either 0, R is either 4, or R is minus 2. Right? From here, your YH, everything is connected to what we learned earlier. C1 e raised to 0t, C2 e raised to 4t minus 2t, right? If you don't want to write 0t, simply write C1. Yeah. This is your YH. Now we talk about YP. YP. Okay. Is a 32x squared, right? So, which is similar to e power this thing from here, right? E2t. So whenever there is exponential, we follow the table which we learned earlier, and this will be some unknown e raised to 2t. That's your yp. But what do we need to obtain? We need to obtain up to third derivative. D cube is third derivative, right? Okay, so we talk about yp dash, which is 2a e raised to 2t, yp double dash, which is 4a e raised to 2t, and yp triple dash, which is 8a e raised to 2t. Right? And our f of x, which is, I call it f of t, it is e raised to 2t. Therefore, your lambda is equal to 2. Right? Right. We have d square minus 2d minus 8. Yp is e raised to 2t. If you want, you can merge them everything. So d3y, where we will use this, minus 2d square y, 8d yp, yyp, same thing, e raised to 2t. Now replace every place. We got all the values that we need. Just replace it there. So d3, that is 8a e raised to 2t, right? Minus 2d square. Now d square is 4a, 2d square will be 8a. So that will be 8a e raised to 2t minus 8 dyp. So that dyp is nothing but y dash. Yeah, if you want, you can add one more step. So y triple dash minus 2y double dash minus 8y dash is equal to e raised to 2t. So that way you can easily plug the values back in. Okay. If it doesn't confuse you, then just skip this step. Yeah. Right. So 8 times 2. So that's minus 16a e raised to 2t. Right. And the right hand side is nothing but e raised to 2t. That get cancel. E raised to 2t gets cancelled. So minus 16a is 1. And a is minus 1 on 16. And finally, that will give you your yp as minus 1 on 16 e power 2t, right? And the final step, y is equal to yh plus yp, which c1, c2 e raised to, it was 2 and 4 here, minus 2 and 4, right? And yp, which is minus 1 on 16 e raised to 2t, right? Now the question was in x. So your answer should be in x. But we have this relation. We just replied, put it back, right? E raised to t is x, right? So e raised to, if you want, how do you write it? 1 over e raised to t square, right? E raised to t power 4. I'm just writing in a way so your substitution becomes easy, right? C2, what is this? 1 over x square. Yeah, or you can write C2 over x square if you want. This is C3 times x is 4 and 1 over x squared. This is your y. It's a very decent long question, which is good and bad, right? Right, so that was everything about Euler. Nothing fancy here. The only thing is your characteristic equation is being taken care differently. We have a fixed substitution, and this YP follows from the only a week 7 or week 6 content, where we follow that special form of fx. If you are confused about lambda, lambda is your right-hand side. Yeah, so lambda is coming up from here, e raised to 2t. So lambda is coming up as 2, right? In week 6, we talked about the form of fx and a corresponding yp that you will choose. And in week 7, we talk special cases of that same table. So this belongs to week 6 content, where lambda is equal to 2 is not a root of the characteristic equation. There, we were only talking about second order differential equation. So we are talking about 2 roots. Here we got 3 roots. Well, roots are 0, 4, and 2. Sorry, minus 2. Lambda is equal to 2 is not any one of the roots. And therefore, we follow week 6 content, where we had our yp as a e raised to 2x, or lambda x in particular. We needed y dash, y double dash, y triple dash, put it back in this equation here, right? And that's it. Yeah, I just wrote it a bit nicely again. It's easy to y triple dash, y double dash, y dash, and right-hand side e raised to 2t. Compare the coefficient, you get your a, your yp, which is a particular solution, should not have a constant. YC will have some constant, YH, I mean, yeah. YP, particular solution, should not have any constant. That's why we are doing this process of obtaining it. Combine your general solution as YH plus YP. Simplify if you can, otherwise leave it as it is. Remember the final step of putting your answer in X. The question was in X. We replaced by substitution of T for our convenience, so we can solve it easily rather than any complex method. Okay. We move to the next part, where we talk about system of ODEs. Okay. Not too difficult part, yeah, but there'll be bit back and forth, yeah, so please observe it carefully. Right. The general process of solving such a system is to eliminate the other unknown function, right, their derivative in the system, so as to create only one higher order linear equation. Easy to solve. Solve this higher order linear equation to obtain the function satisfying the ODE, and then we use the substitution, right? Substitute the obtained function into the original system to determine the other unknown. Like the same simultaneous system of equation, this is what we do. Yeah. Okay, so let's look at an example. This is what it will look like. dx by dt is 2x plus y, dy by dt is x plus 2y, some initial conditions, right? Okay. There'll be bit back and forth, so please hold it carefully, right? Okay. Let's start. dx by dt, change to blue, is 2x plus y. Okay. If I want to obtain y from here, y will be dx by dt minus 2x. That's my y. Okay. If I wanted to obtain the differentiation of this with respect to x, because I wanted to replace it up here. Okay. So what will that look like? So dy by dt, right? Differentiation with respect to t, right? So this is already t, so d2x by dt squared minus 2 dx by dt. Okay, right. You can call it x double dash x dash, easy to write. Okay, now what is this? Is dy by dx. So can I call it x plus 2y is equal to x double dash minus 2x dash. We are almost there, but we still have a y in our equation. Okay, so we cannot handle. See, as I always say, you cannot handle 3 variables in a differential equation. Maximum you can handle is 2, x on one side, y on the other side, or x on one side, t on the other side. But if you look at the question here, you got x, t, and y, and that's the whole step. No fixed step method here, as long as you can eliminate one of them, preferably y or x, of course, and then get an equation which either contains x and t or y and t. Here I am eliminating y and getting an equation in x and t. Right. So just this bit, once I replace my y, how can I replace my y? I can say it from here, isn't it? I got it here. Okay, so x plus 2 times dx by dt minus 2x is x double dash minus 2x dash, right? Okay, but I have written x dash, so I'll write it 2 plus, sorry, x plus 2x dash minus 2x is equal to x double dash minus 2x dash. Awesome, we got everything in x dash, which is x and t. We just write a bit nicely and combine everything. So we got x double dash minus 2x dash. We take this 2 on the other side, so another minus 2x dash, and x minus 4x will be minus 3x, so that will be plus 3x, right? Okay, so minus 2x dash plus 3x is 0. Simplify it again, so x double dash 4x dash plus 3x is 0, right? So that's an equation, differential equation with x and t, similar to what we have been doing, right? It's a homogeneous differential equation because the right-hand side is 0. We talk about its characteristic equation, r squared minus 4r plus 3 is 0. It will give you r is equal to, I mean, you factorize it, right? R minus 3, r minus 1 is 0. R is 3, r is equal to 1, right? And therefore your x, which is c1 e raised to t, ct e raised to 3t, right? And then what we do, we got our x. We still need to find the y. Now, if you go back, what was your y? Y was dx by dt minus 2x, right? So we need dx by dt. Or you call it x dash, same thing, yeah? c1 e raised to t, 3ct e raised to 3t. That's your dt by dx, right? Once we obtain that, our y was dx by dt minus 2x. So that's c1 e raised to t, 3c2 e raised to 3t minus 2 c1 e raised to t, c2 e raised to 3t, c1 e raised to t minus 2c1, so that will be minus c1 e raised to t, and 3c2 minus 2, so that will be c2 e raised to 3t. So that's your y, right? Okay, we are not done yet because that's your x and y. I'm happy to write it again, so we have it nice and clear. X is C1 e raised to t, C2 e raised to 3t, and y, which is minus C1 e raised to t plus C2 e raised to 3t. This is your x and y, absolutely. But that's a general solution, not the particular one. If you go back to the question, it has given us some condition, right? X of 0 is 3. So that's your t, that's your x, that's your t, that's your y. So I write the condition here. X of 0 is 3, y of 0 is 1. That means t is 0, x is 3, y is 1. We put all the values here. So 3 is equal to C1 e raised to 0. So that's gone. That's gone. 3 is equal to C1 plus C2. And up here, 1 is equal to minus C1 plus C2. We solve it. Once you add them, you will have 2C2 is equal to 4. C2 is 2. Once you have your C2, 3 is equal to C1 plus C2. And therefore, your C1 will be 1. That's it. We got C1 as 1, C2 as 2. Your final particular solution, x, will be e raised to t plus 2 e raised to 3t, and y is equal to minus e raised to t plus 2 e raised to 3t. And that's your final x and y. Right. So just to again explain a bit here, once you got your, t, oops, come on. Once you got your t, x, and y, you plug that in here. Since e power 0 or e power 3 times 0, they both will be 1. I just cut down one step just to minimize the length. X, which is 3, C1 e raised to 0, that is just C1, C2 e raised to 0, that's just C2, that's your y, minus C1, same thing. You add them, I return a note here, add them. Why we add them, it's up to you how you solve it. Addition with one being plus, other being minus is lot quick. You just add them. So C1 is gone, 2C2 is 3 plus 1, 4. C2 is 2. Plug it back here. You'll get your C1. This C1 and C2, you use it to plug in the X and Y solution to get your final particular solution without constant, right? Let's take the next example. Dx by dt plus x is y, dy by dt minus 2y is 4x minus 6. Okay? Cool. This is very easy to start with. Reason being, you already have the value of y. Up here, you're talking about dy by dt. It's just differentiate it once more. And that's it. Okay? Right. So from here, if I differentiate it, can I get d2x by dt square plus dx by dt is equal to dy by dt, right? I will also replace this y. So this is in x, so that's fine. Okay? What happens right now? You got x, y, and t. Again, my priority is to get rid of y. Just bring x and t, one on each side, right? dy by dt, that will be taken care of. That will be x and t. I still got 1. Okay? So mine is 4x minus 6. I'll replace dy by dt. I'll replace my y, and that's it, right? So this is x double dash, if I have to write it that way, plus x dash minus 2y. Y I will replace it from this equation. x dash plus x. That's it. This is equal to 4x minus 6. Right? So x double dash, x dash minus 2x dash will be x dash negative minus 2x. Bring everything here. So that's minus 6x is minus 6. Right? You can call it minus 6x power 0 as well if you want, just to compare it with the lambda and all the things, right? You don't want it now. Just keep it simple. Once you reach here, that is your R thing will begin, the equation. So R square minus R minus 6 is 0. 2 roots R minus 3, R plus 2 is 0. R is 3, R is minus 2. The roots cannot be similar to that, and that's why you have to write x power 0 just for your power not being equal to the root, right? Simply take it that way. We cannot afford to forget what we have learned because everything is building up, right? So if you forget how to obtain this auxiliary equation or next step from here, or what is that lambda, what is that, and keep in mind, if you can't fit everything in your mind, keep the literature in front of you, keep the slides printed, keep the book open, right? And then keep comparing it so every step makes sense. Right, we adopt the same notation xh, c1, whatever root, our root was 3 and minus 2. Yeah, okay. c1 e raised to 3t plus c2 e raised to minus 2t. xh or h is xh is the homogeneous thing, you know. Right, since my n is 0, again we follow to week 6 content, you know. My xp is simply a, right? Because a xn, right? So xp dash or xp double dash will be both 0, right? We plug in this equation here. I call it equation number 3 because I call this 1 and 2. Right. So from 3, 0 minus 0 minus 6x, so that is 6a is minus 6, which gives my a is 1, and therefore my xp is 1. Awesome, nice and simple. xp is 1. And finally, my xp is 1. My x is xh plus xp, which is c1 e raised to 3t, c2 e raised to minus plus 1. Now, the question you might have is, why do we go for x, h, and xp here, but in the previous question, we didn't go for it. We just went for one part of it. The difference is homogeneous and non-homogeneous equation. If you look at this question or this equation that you are solving, this thing here, this thing here, this equation is non-homogeneous. When you look at the earlier question, what you were solving, this equation, it was homogeneous. So if it's a homogeneous, you follow homogeneous path where you just talk about the root, nice and easy, simple stuff. Don't worry about the YP part. Okay, again, we cannot forget what we learned. What we do with a homogeneous differential equation, that has to be extremely clear in your mind. But what we do, if it is a non-homogeneous equation, when the right-hand side non-zero, what do? We talk about the YH part. We talk about the YP part. In this instance, the variable is X. We talk about the XH part. We talk about the XP part. Combine it. That's your solution, right? So that's what we have done. Before you raise that concern, that what's happening here in your mind, this is your X part. Now, once you obtain the X part, we are talking about system of linear equation. So from your X part here, We wanted to have y from equation 1, as you can see it here. Equation 1, this bit here. What do I need in order to find my y? I need dx by dt. I need by x. I already got my x. I don't have my dx by dt. I'll obtain my dx by dt, right? And that's it. Add them together to obtain your y. And no initial conditions, so whatever that remains is your answer, right? Okay, so we do that. I call it equation 1. I'll change the pen color to blue. Y is equal to dx by dt plus x. Now dx by dt, so we talk about dx by dt. We differentiate this one. If you want, you can call it dx by dt here as well. So 3c1 e raised to 3t, 2c2 e raised to minus 2t, and one differentiation is 0. So this is my dx by dt as well, right? Plug it back in. 3c1 e raised to 3t plus, minus 2c2 e raised to minus 2t plus c1 e raised to 3t, c2 e raised to minus 2t plus 1. Combine it where you can. Obviously, you have 2c1. So combine it, 4c1 e raised to 3t minus c2 e raised to minus t plus 1. That's your y. You got your x, you got your y. Just write them nicely, combine in a final step. Your x, which was c1 e raised to 3t, c2 e raised to minus t plus 1, and y is 4c1 e raised to 3t, c2 e raised to minus 2t plus 1. That's your x and y. That's easy. C1 and C, x and y. Cool. Cool. So let's go to our last example. Again, nothing tricky here. It's just, X, Y, and Z rather than T. And let's look at that one. Okay. So we'll start with getting rid of Z, right? So here, your 2Z is dy by dx plus y, right? Okay. So if I wanted to talk about Z, it is half of dy by dx plus y. Okay, so that's my Z. We'll take a note of that one. What I need is d2z by dx2. So for that, I will talk about first derivative to start with. So dz by dx. Half stays as it is. D by dx of this internal ring. And that will be half. This will be d2y by dx2 plus dy by dx. This is dz by dx. What I need is second derivative. d2z by dx2, right? So that's half d by dx of this internal d2y by dx2 plus dy by dx. Right, so that's d3y by dx3, d2y by dx2. Okay. Now, I will call it a couple of equation 1, 2, 3. Okay, I wanted to have everything in x and y. If I look at equation 2, I have d2z by dx2, which I obtain x and y. This is in y, z, which I'll replace here. Okay, so from 2, I write equation 2 again. D2z by dx2 is 2y minus z. Now I plug in all the value. Which values I will plug in? I will plug in this, which is x and y. I will plug in my z. So everything will be x and y. As we know, we can only handle 2 variables, right? So that will be half d3y dx3 plus d2y dx2, right? If you observe, this is 2y minus z. Y will leave it as it is. Z will replace the value from 3. So that is 2y minus half. What do we have? dy dx plus y. Simplify. I would multiply everything by 2. So this will be d3y dx3 plus d2y dx2. This will be 4y minus dy by dx minus y. Okay, and simplify this. Bring everything on the left-hand side. Keep the y term, right. So d3y dx3 plus d2y dx2 plus dy by dx. This becomes plus 3y here, so minus 3y. You can represent this in the form of capital D or however you like, or simply, this is third order, second, first. So talk about R3 plus R square plus R minus 3 is 0. Okay. How you split that? You have to see if R is equal to 1 is a factor. So, R minus 1, if it is a factor, R is equal to 1. When you replace it in the polynomial, it should equate to 0, which it does, right? So R3 plus R square, we need R minus 1. Okay, so we arrange it. There are many ways you can factorize this. If you know nothing, long division, polynomial division is the key, right? How do we do it? That was learned in our first year. R square plus R minus 3 divided by R minus 1, then is R square, then is R3 minus R square minus and plus, and you keep going, right? Or there is a second approach, which is a lot quicker, especially in a longer question like this. You have to bear in mind that you are taking R minus 1 common. So if I start with R, I'll start on the next page, next slide. Okay, I have my R3, R square. Okay. What I need is R minus 1 common at each stage. So when I multiply this, I got R3. The next term is minus R square. Now I got positive R square. I got minus R square because of term arrangement. In order to do that, I will need plus 2R square, right? Now if it is plus 2R square, I need another R minus 1. So when I multiply plus 2R square minus 2R, I needed an R. I got minus 2R. What should I add? I should add plus 3R. Right? And finally, when you multiply, you have 6 terms. So technically, your 4 term from this step, you have rearranged into 6 terms. In a way, your R minus 1 is common. Okay? If this is complex for you, don't worry. Follow the long division. You'll have something which is exactly R square plus 2R plus 3y. Okay, now R square plus 2R plus 3. Can you split it using product sum method or AC factors? 3 split it up to get 2, not possible. So you'll have to go for the discriminant thing. And your discriminant, you will have complex root from here because B square minus 4AC will be less than 0. So your R minus 1 up here So that will give you, sorry, I'll just write everything here. So R is equal to 1, or your R square plus 2R plus 3 is 0. Obviously, you can't factorize it easily. So what we have, R is equal to minus B plus or minus B square minus 4AC over 2A. Right? So minus 2 plus or minus 4 minus 12 is minus 8. So I'll write everything minus 8 here in this step over 2. Minus square root 8 is I squares root 8. It is 2 root 2. So minus 2 plus or minus I 2 root 2 divided by 2. Cancel 2 from everywhere. So it's minus 1 plus or minus I root 2. That's my another R. So I get 3 values of R. Right? Up here, I will call it alpha is minus 1 and beta is root 2. Okay? Right. Again, it's the homogeneous part, right? This is my R value. So here we are talking about everything of Y. So my solution will be Y is equal to C1 e raised to R1x. I'll write everything if you want, plus C2. Now it is a complex. Whenever it's a complex, we follow the alpha approach, e raised to alpha x, C2 cos beta x, C3 sine beta x. Okay, so that is C1 e raised to x, because your R1 is 1, e raised to alpha x, alpha is minus 1, C2 cos beta, which is root 2x, C3 sine root 3x. This is my y. I got my y. Now I need to find the z. Right? Do we have a relation somewhere? Yes. Z is equal to half equation 3, dy by dx plus y. Okay. So from 3, my z was half dy by dx plus y. Okay. So therefore, your z is half dy by dx, a differentiation of y. Okay. So C1 e raised to x. Here will be a product rule. Okay. So we'll leave e raised to minus x as it is. C2 cos differentiation is minus sine. Multiple goes in front. Plus, is it root 2, root 3? Sorry, root 2. So that is 2. C3 cos root 2x plus C2 cos root 2x x. So that's your dy by dx plus y. Okay, what is our y? Is a whole this thing. C1 e raised to x, e raised to minus x, C2 cos root 2x, C3 sine root 2x. Right? And then you simplify where you can, whatever you can take common, right? Okay. I'll have to flip the slide, but please be careful when you flip the slide. Okay. And therefore your z is half, right? Okay, C1 and C1 will be 2C1 e raised to x. I take e raised to minus x common from everywhere. So e raised to minus x. Now I got this one is sine root 2x. This one is sine root 2x. I can combine and one more sine root 2x, right? So there are 3 terms with the sine. And with the cos, I got one of the cos, second and third. That's what you're combining, right? Okay, so what we got? Minus root 2c2 root minus C3 and plus C3, that will be gone. Okay. Right, I'll write it here. Okay, let me write the constant first. So I get minus root 2 C2. And root 2x plus. Same thing here, root 3 C3 minus C2 plus C2, so they will be gone. So that will be root 2 C2 minus C3 plus C3 cos root 2x, bracket close, and for your z is half 2C1 e raised to x, e raised to minus x. We can see root 2 is common everywhere, so let's take it out. Root 2, and therefore we'll be left with, sorry, did I miss the constant? Yes, I definitely mixed it. That's C3, that's C2, and that's C2. So 3 cos root 2x minus C2 sine root 2x. And that's your z. So you got your y, you got your z, and that's what you needed. Right. Okay, dokie. Now that will be the end of the session. Apologies if you find it a bit difficult. Can't help you with the difficulty level of it. We'll try to make it simple. Please get in touch if you struggle with any of the concept. Thank you very much, and I'll see you next week.